Welcome to the Test 3 review for Math 310. The first problem is to add these two rational expressions. To do that, we need to find a common denominator, and we do that by factoring each of these denominators and then finding out what we need to do to make them common denominators. Here's the first denominator. It factors to x plus 6 squared. The second denominator is the difference of squares, which factors to x plus 6 times x minus 6. To find the common denominator, we look for unique occurrences when we compare the two denominators. For instance, x plus 6 shows up here and here, but this one has the highest exponent, so we circle it and cross out the other one. And then x minus 6 is unique. It doesn't show up anywhere else, so we circle that one. Now we write down for our least common denominator all of the things we've circled, which is x plus 6 squared and x minus 6. Coming back over here, our factorization of x squared plus 12x plus 36 is x plus 6 squared. So I've just rewritten this first term and this second term. Now what we find is that in order for this to be the least common denominator, we need an x minus 6 in it. So we multiply top and bottom by x minus 6. In this denominator of our second term, we have an x plus 6 and an x minus 6, but we're missing the other x plus 6. So we multiply by x plus 6 over x plus 6. And that gives us 6x minus 6 times 6 plus x plus 6, all of that over our least common denominator. We're able to do that because we have the same denominator in both cases. And if you look at this, you'll see that x plus 6 squared is the same thing as x plus 6 times x plus 6. So distributing the 6 in the first term, we have 6x minus 36 plus, and then the 1 is just x plus 6, all of that over x plus 6 squared times x minus 6. So combining like terms, 6x plus 6 is 7x, minus 36 plus 6 is minus 30, over x plus 6 squared times x minus 6. And since there are no common factors in the numerator and there are no common terms in the numerator and denominator, then we are finished. On our second problem, which is 3 over t plus 7 over t squared, all we need is a common denominator, which would be t squared. So we multiply the first fraction by t over t, and that gives us 3 over t squared plus 7 over t squared equals 10 over t squared. In this problem, we already have a common denominator of 3 plus y, so we can simply add the numerators. 5 plus 2 gives us 7 over 3 plus y, and we're done. In this problem, we have different denominators. Our least common denominator is going to be x plus 7 times x minus 7. So in the first, we already have the x plus 7, so we need to multiply by x minus 7 over x minus 7. And in the second, we already have the x minus 7, so we have to multiply by x plus 7 over x plus 7. And now we have the same denominator, so we can simplify the numerators. First, we're going to distribute the 3, and then we have a minus, and then we're going to distribute that 1. But we have to keep the parentheses so that we know that minus sign gets, because a minus is the same thing as plus negative 1. And we're going to distribute that negative 1 to both terms. I'm going to just do this so I don't have to keep rewriting. So we have 3x minus 21 plus negative x plus negative 7 over that least common denominator. And so 3x, combining like terms, 3x minus x equals 2x. And then minus 21 minus 7 gives us minus 28 over our least common denominator. But let's go ahead and pull out the common factor, which is 2, and that leaves us with x plus 14 in the numerator over x plus 7 times x minus 7. Okay, we have to reduce 40 over 22. There's a 2 in 40 and a 2 in 22. 40 divided by 2 is 20. 22 divided by 2 is 11. And that's all there is to that problem. This is another easy problem if you know how to handle your negatives. A and negative a are in the denominator, but the 5 over negative a is the same thing as negative 5 over a. You can put that negative in front of either number. If you put it in front of the 5 instead of in front of the a, we now have the same denominator. So we have 2 minus negative 5 minus a negative is plus a positive over the common denominator, which gives us 7 over a. Now we're going to multiply. We have a binomial over x, and then we have another binomial over a trinomial. So let's factor what we can. The first one, we can't factor that factor at all. But the second one, in the numerator, we can pull out an x, leaving us with an x minus 2. And then in the denominator, we can factor it to be x plus 3 times x minus 2. And now we can cancel like terms. The x's go away, and the x minus 2's go away, and the x plus 3's go away. Now here's where you need to be careful. Every time you canceled, what you're leaving is a 1. So we have 1 times 1 times 1 equals 1 in the numerator, 1 in the denominator. So our answer is going to be 1. In this problem, let's start by pulling out common factors. That's what you should do all the time. We pull out a 3a, and 3a squared divided by 3a is a. 3a divided by 3a is 1. Don't forget that 1. In the denominator, we have a 3 that goes into 9 and 6, and we also have an a. When we divide 9a squared by 3a, we are left with 3a. 3a times 3a equals 9a squared plus, and then 2 is left in the second term. 3a times 2 is 6a. Alright, now we can cancel out those 3a's. There's nothing else that we can pull out, so we have 1a plus 1 over 3a plus 2 for our answer. This time we have a division problem. Let's do a couple of things at once. Let's factor where we can, and we can in the numerator of the first factor. So instead of a difference of squares, we're going to add the roots and subtract the roots. That's the same thing as b squared minus 25. We still have b plus 1. And then now we're going to use our KFC for division. We're going to keep the first, flip the second, which gives us b over 5 minus b, and change the division to multiplication. Okay, if you notice, the b minus 5 looks kind of like the 5 minus b, but there's backwards. You can flip around the 5 minus b if you put a negative sign in front. In other words, 5 minus b equals negative b minus 5. So that's what we're going to do. We're going to rewrite b plus 5, b minus 5, over b plus 1 times b over negative b minus 5, which helps us because then this and this cancel out, and that's all that cancels out. Don't forget that negative. Let's pull the negative in front of everything. So now we're going to have negative b plus 5 times b. I like to write my monomials in front, because remember, in multiplication you can move things around. Here we have y squared minus 81 over y plus 4 divided by 9 minus y over y. We're going to do the same thing we did earlier. We're going to factor where we can. Y plus 9 times y minus 9 equals y squared minus 81. We still have that y plus 4. And then we're going to flip the second, because we have division, and change division to multiplication. Okay, here we have the same kind of thing. We have 9 minus y, and all we have to do is put a minus sign even in front and change this to y minus 9. That's a little trick we can have, because 9 minus y is equal to the negative of y minus 9, and we can move that negative in front. So now we can cancel our y minus 9, and we are left with a negative of y plus 9 times y over y plus 4. And like I said, I like to put my monomials in front, but it doesn't matter, over y plus 4. Here we have a subtraction problem, and we have different denominators. Let's write them out over here. We have 25 z cubed y, and we have 35 z squared y. Alright, let's write it in terms of primes. 25 is 5 squared z cubed y, and then 35 is 7 times 5 z squared y. Alright, now we compare both of these denominators and find the unique occurrence of everything. 7 is unique, so we're going to circle it. There's not a 7 anywhere else. There are 5s in both cases, so we circle the one with the largest exponent and cross out the other one. Same with z, and then we need only one of these y's, so we can choose either one and cross out the other one. Okay, what we're left with is, I'm going to write it all down, 7 times 5 squared are the numbers. We have z cubed and y. And 5 squared is 25, so we need 7 times 25, which is 175 z cubed y. That is the common denominator. Okay, if you come back to your problem, we have 7 over 25 z cubed y, and we need to multiply it by something to get 175. If we multiply it by 7 over 7, we will get that. Now in the other case, we have 1 over 35. Oh, I didn't do the variables. We already have z cubed y in the first case, so we don't need to do anything about the variables. But in the second case, we only have z squared y. So to get 35, you have to take 175 and divide it by 35 to see what you need to multiply by, which it is going to be 5. So we're going to multiply by 5 over 5. And then we need to also multiply by a z over z in order to make that z squared into z cubed. And we already have the y, so we don't need to do that. Now 7 times 7 is 49. 7 times 25, well, we already know we're going to have 175 z cubed y. That was our whole goal, and I'm not going to write it twice. I'm going to go ahead and combine the numerators. 1 times 5 is 5z. So we have 49 minus 5z over 175 z cubed y. We cannot cancel z's because there's no z by the 49. So, and we can't pull out anything because there's not a common factor between the 49 and the 5z. So this is our final solution. Here's another subtraction problem. By now you probably know from practice that the least common denominator is going to be x plus 1, x minus 1. So here's our three denominators. If we circle the unique occurrence of everything, that would be this, and we can ignore these. And so we rewrite the expressions. For x, we have x minus 1. We need x plus 1, so that's what we're going to multiply top and bottom by. Minus 2 over, we have x plus 1. We need x minus 1's. Minus 4, and we already have x plus 1, x minus 1. Now we have the same denominator everywhere. So we are going to keep that denominator. We're going to have x plus 1, x minus 1, and in our numerators we're going to distribute 4x times x is 4x squared. 4x times 1 is 4x minus, and then I'm going to put a parenthesis so we don't mess up our negative signs. So keep that minus separate, and then whenever you have a minus, use a parenthesis next. 2 times x is 2x. 2 times negative 1 is negative 2 minus 4. So let's now distribute that negative in here. It's just like adding a negative 1. The negative 1 there. And that gives us 4x squared plus 4x. And then distributing that negative 1, we have plus negative 2x plus negative negative 2, which is plus 2 minus 4. So this negative 1 times this negative 2 gives us this plus 2 over the LCD. And so that gives us 4x squared plus 4x minus 2x is 2x plus 2 minus 4 is minus 2 over the LCD. And we can see that we can factor out a 2 from that, leaving us with 2x squared plus x minus 1 over the LCD. Now I'll quickly take you through factoring. There are a couple of ways of doing this. The way we've done it in class is for 2x squared plus x minus 1, we multiply the 2 and the negative 1 and we get negative 2, and then the coefficient of the x term is 1. We need two numbers that multiply to give us negative 2 and add to give us 1, and so that's going to be 2 and negative 1. But at that point we don't, now that I know it's 2 and negative 1, I don't need that bar, and that'll give me more room to write. Let me do this so we know we're having a practice space over here. So I rewrite 2x squared, and then I use these numbers, my negative first, minus 1x plus 2x, because that makes plus x there. Alright, and then I write my minus 1 there, and then I group. So in the first case, my common factor is an x, and I'm left with 2x minus 1. Plus, and I already have a 2x minus 1, so I'll put a 1 in front of it, and so it factors to 2x minus 1 times x plus 1. So here I rewrite all of that, 2 times 2x minus 1 over times x plus 1 over our least common denominator, which is x plus 1 times x minus 1, and what can we cancel? We can cancel the x plus 1's. We cannot cancel 2x minus 1 and x minus 1 because they're not the same thing. So it has to be exactly an identical binomial, and that's our final answer. We had a problem similar to this before, and we found out that our LCD was x plus 1 and x minus 1. So we have 47x over, and we have our x minus 1. We need an x plus 1, so we multiplied top and bottom by x plus 1. That doesn't look right. Let me erase it and put plus. And then our 94 already has both of them. All we're going to do is factor out the denominator. And then the last term, 47x over x plus 1, is missing the x minus 1, so we multiply numerator and denominator by that. Now we have the common denominator. So let's simplify our numerators. 47x times x plus 1 is 47x squared plus 47x. Our next term is simply 94, and then we are subtracting, and so remember, put a parenthesis. 47x times x is 47x squared, and then 47x times negative 1 is minus 47x. All of that over our least common denominator. So I'm going to take this last term, minus 47x squared minus 47x. I'm going to simplify it over here. Negative 1 times 47x gives us negative 47x squared, and negative 1 times negative 47x gives us positive 47x. So when I rewrite this, I'm going to go ahead and just erase it because I'm running out of room. Gives us minus 47x squared plus 47x. So we have 47x squared minus 47x squared. Those cancel. 47x plus 47x gives us 94x plus 94 over our least common denominator, and obviously we can pull out a 94, and we're left with x plus 1 over, and then our least common denominator is x plus 1, x minus 1, and we can cancel the x plus 1's, and that gives us 94 over x minus 1. In this problem, it asks us to find the numbers that are not in the domain and then give the domain. When you're asked a problem like that, you don't care anything at all about the numerator. All you care about is what will make 3x minus 7 equal to 0. Because, whoops, we're back. Because if 3x plus 7 equals 0, then that means the denominator is 0 and that function is undefined. So to find out what x has to be to make 3x plus 7 equal, or minus 7 equals 0, we add 7 to both sides and then we divide by 3. So the number that they're asking for in A is, here's A, x cannot equal 7/3. So you just simply enter 7/3 in the space provided. And B, they want you to write that in set theory, and they call that giving the domain. And that looks like this. X such that x cannot equal 7/3. Okay, to reduce rational expressions, then you just need to be able to factor them. And factoring these, you have to use grouping. So let's go ahead and do this one. I need to multiply 3 by 35. I'm not going to actually multiply it, and I'll show you why in a minute. And then I need those two numbers that multiply to that to add to negative 22. So I know they need to be negative numbers because they have to multiply to be a positive but add to be a negative. I broke 3 times 35 down to primes, 3 times 7 times 5. And I'm going to try different combinations. 3 times 5 is 15, and then 7. Let me try that combination. And they have to both be negative. Negative 15 plus negative 7 equals negative 22. So see, that isn't that hard if you're smart about it and break it down to its primes. So we now do what we did before, 3y squared, and this time both of them are negatives. So I'm going to put a plus in the middle and then put minus 7y plus 35 so that I can group. Minus 15y plus minus 7y equals minus 22y. And when I group, my common factor, keep doing that, my common factor is 3y, leaving y minus 3, plus, and then I'm going to pull out a negative 7, leaving y minus 5, and this here should have been a 5, not a 3. So these two binomials are the same, leaving me with y minus 5 as one of my binomials and 3y minus 7. I'll just go ahead and do that now. Okay, so my numerator boils down to y minus 5 times 3y minus 7. Now I'm going to do my denominator. I'm going to erase a few things to give us room. In my denominator, I'm going to do the same steps. 3y squared plus 11y minus 42. I need two things that multiply to 3 times 42, really a negative 42, and add to 11. And this time I need a positive and a negative, and my largest one has to be positive because it adds to a positive, but they multiply to a negative. So 42 times 3, let's break that up into its prime. 3 times 6 times 7 is 42, but that's not quite prime, but we're going to play around with that and see if that'll help. 7 times 3 is 21. 21 minus 6 gives us 15, so that won't work. 6 times 3 is 18. 18 minus 7 is 11. So let's do 6 times 3 is 18 and negative 7. And they add to 11. So those are our two numbers. Rewriting those, we're going to put the negative first. And then pull out a common factor. And then our 3y minus 7 is another common factor, leaving us with y plus 6. Okay, so going back to our numerator, I'm just going to draw it like this. We can put our denominator down here, and you can see what happens. The 3y minus 7 cancels, and you're left with y minus 5 over y plus 6. This problem is easy if you remember to factor out your common factors first, and also when you factor out a 3p from your 3p, you're left with 1, not 0. So you have your numerator is 3p times p minus 1 over 7 times p minus 1. Then your p minus 1's cancel, and you're left with 3p over 7. Here's a simpler problem than we had before for reducing. All we have to do is factor the numerator, factor the denominator, and then see what cancels. So in the numerator, we know that 7 times 3 is 21, And we know that both numbers have to be negative to add to negative 10. So we have x minus 7, x minus 3. In the denominator, we need to add to a positive number, but multiply to a negative number. So we know that the largest is going to be positive. So here we have x plus 7 times x minus 3. And you can FOIL it to make sure I factored it right. But now our x minus 3's cancel, and our final answer is x minus 7 over x plus 7. And this is a very easy problem because it's already all multiplied out. All we have to do is cancel things. We have this x minus 3 and this one. We have this x minus 4. We have x plus 2. And we're left with an x plus 6 over x minus 3. Okay, again we're going to factor our trinomials in the denominators. So the first term had d plus 9, d plus 10, and the second one d plus 9, d plus 8. So our least common denominator is going to be d plus 9, d plus 10, and d plus 8. And we're missing the d plus 8 in the first one, so we're going to multiply top and bottom by d plus 8. Whoops. And in the second one, we need to multiply by d plus 10 over d plus 10. So now, simplifying the numerators, we get d squared plus 8d minus, parentheses, 9d plus 90 over our common denominator equals d squared plus 8d minus 9d minus 90, which is d squared minus d minus 90 over, I'm going to do it again because I'm going to factor the numerator to be d minus 10, d plus 9 over, and now I'll write out my least common denominator. Because I can cancel out the d plus 9's. I can't cancel out anything else. So then I'm left with d minus 10 over d plus 10 times d plus 8. And that's our answer. And that brings us back to the end of the video. So I've gone over things pretty fast, but you'll be able to pause it or slow it down as you desire. Let me know if you have any questions.